All right, folks, let's get started with Java in our ColdFusion apps. I hope you all can hear me. Um, Before I start the session proper, I'm going to leave this slide up here for a minute. If you go to that URL, bit.ly/cf-java-2021, you'll be taken to the slides for this session and you'll be able to follow along. They'll move as I progress the slides. So you might be able to see them larger on your screen, or if there's any video issues, you'll be able to follow along with the slides. So that's there. If you follow that link, you can follow the slides on your own machine. I prepared an hour-long talk for a 50-minute session, so I'm going to go fast, and I apologize for that. But like the slides are here, they'll be shared after the fact, and all the code will be available. So don't worry if you miss something, and I apologize in advance. Without further ado, a session about Java is, of course, a great excuse to use lots of stock photography with Java, coffee, the Java islands, their beautiful rock formations and beaches. And while we're on the topic of things that will not be covered in this session, I like to start with things that I won't be covering so that I don't waste your time. So this session is not going to be a session on how to write Java. If you're interested in that, I've included some links here. There's all manner of tutorials on YouTube, beginning at Learn Java in 14 minutes, unlikely, to full-length master classes on Udemy. So if you're interested in learning how to write Java, that's not going to happen today, but there's some resources for you. This is not a session on Java upgrades. I can't tell you, well, I probably could, but I'm not going to tell you how to upgrade your ColdFusion version of Java. Again, some resources here. Charlie Earhart has a guide. Pete Freitag has a really detailed guide, and Adobe has their various support matrices, so those might be of use to you. It's not a session on which Java version or which Java distro you should be using. Again, here are some resources. There's a lot of different takes on this. Pete's guide is great. That first link walks you through all the different Java distros, and Charlie, as always, has a thorough resource. So more resources. Finally, this is not a guide on how to configure your JVM or tune it. I can't tell you how to track down that memory leak that's been plaguing your application, but someone who can is Charlie Earhart. The tools that you might use are Fusion Reactor and the ColdFusion Performance Monitoring toolset. I'm not going to cover that today. I'm sorry if you were hoping that I would, but hopefully those resources there are helpful to you. Now you're probably wondering, okay, what are you going to cover? We will be covering using Java in your ColdFusion apps. I'm going to talk about when and how we might do that. I'm going to tell you when you don't need Java. There's a bunch of instances where you might have thought you would and you don't need it. And I'm going to have lots of code examples. Pretty much everything in here will have the code, because I like things to be practical and you actually to be able to use the code that I provide. Another note here, this is a getting started session. So if you are a Java guru, it will probably be too beginner for you. If you've used Java in some apps, there'll probably be some tips in here that you're not familiar with, but it is a getting started guide. Now, when I started preparing this session, one of the topics that I considered addressing was the relationship of Java and ColdFusion. And I could present, something breaking down how your ColdFusion code becomes Java bytecode and the JVM and the JDK, et cetera, but that's not really necessary if we're just talking about how to use Java in your ColdFusion apps. All we need for this session is to know that Java and ColdFusion play really nice together. And as a ColdFusion developer, because ultimately our code is compiled down to bytecode, we can take advantage of Java when that makes sense. Another note up front, Java can be intimidating. I know that when I first started using a bit of Java in my ColdFusion apps, I was certainly intimidated. If I encounter a new Java library that I'm trying to work with, frequently I feel overwhelmed. This is a totally normal thing, even for seasoned developers, and that's fine. I have some footage here. This is me using Java for the first, second, third, fourth. This is just me using Java frequently. You know, a lot of times I make a mess. But if we take this one step at a time, with small steps, you can integrate Java into your apps and then gradually grow to leverage its power in more robust ways. So without further ado, let's get started using Java in our apps. The first question is, okay, you know, we have ColdFusion, so when might it make sense to use Java? Occasions for using Java include if there is a Java library that you'd like to take advantage of, and I'll talk about some of those at the end, but there's tools like JSoup and Antisamy and AWS's SDK where you might need to leverage Java. There may be version limitations. Not all of us are on ColdFusion 2021, and Java sometimes provides functionality that you might not have in the version of ColdFusion that you're using. You might want to just extend functionality. There are some things that Java does that ColdFusion doesn't do, or at least doesn't do yet. And so you might want to take advantage of that rather than having to write extra ColdFusion code. And finally, there are cases where you might want to drop into Java for performance optimization, although I will say they might not be as frequent as you would think. I like to think of ColdFusion as my toolbox. It has the tools that I need to build the apps that I'm doing. It might even be more than a toolbox. ColdFusion is even like my whole workshop. It has everything when I want to go out and build something that I can grab onto. But if we're going to extend this metaphor, and ColdFusion is my toolbox or my workshop, Java is almost like the whole hardware store. I've gone to a hardware store and you walk down the aisle looking for one thing and you see tool after tool after tool that you didn't even know existed. Java can be like that. It has tools that you didn't know existed and tools that you don't have in your toolbox or home workshop. And in that way, it can be really useful to us. So that's what we'll be exploring. All right, we know when, but how are we going to utilize Java? Well, this is pretty basic here. The way that we use Java is using the create object function. And the first parameter we pass in is Java. And the second parameter is the path to the Java class that we want to use. So in this case, we'll run this code. I'm going to run most of my examples on CF Fiddle here. We are creating a system object and dumping the getEnv function, which shows the environment variables on the system. So creating Java objects, we use create object. Now, if you are running ColdFusion 2018 or newer, there's actually a slightly nicer syntax. You can use new Java and pass in the path, and that will do the same thing that create object does. So this will generate the same results using that new Java syntax. That's really nice. If you're on ColdFusion 2018 or newer, certainly use it. In this session, I'll be using create object just because it's the more common way of creating Java objects, but know that this option is here. Now, the way we take advantage of Java, the way we get into that hardware store is using Java's standard library. In terms of programming languages, Java's standard library is massive. It's super big, it's overwhelming, and there's a lot there. And in this session, I'll be going through some of the classes and functions, because the standard library is what Java provides to us out of the box, all the standard stuff. We'll be going through some of these that we can utilize in our ColdFusion code. So the format I'm going to take for exploring the standard library is questions that I've encountered while developing ColdFusion, and then the standard library Java way that we could answer those questions. And the first one will be, what version of Java is ColdFusion using? Since that seemed relevant to our session. We can do this again with the Java Lang system class. A bunch of these examples here are going to use Java Lang system. We create that system object, and then we use get property, java.version, and we will get the version of Java that is running. So if we run this on CF Fiddle, we'll see that the version of Java being used there is 1107. And if we run it on try CF, you'll see the version here is different. They're using 1.8. Now, a note, if you want to know the version, you might not need Java here. If you're using ColdFusion 2018 or newer, there is the server.system.properties.java.version, and you can dump that, and that will give you the version of Java that's running, as you'll see here. Now, this isn't available on CF Fiddle because they have it blocked for security reasons, but you can see on TryCF that 1.8.222 is the same that we got in the previous example. Moving right along, how do I access environment variables? If you're trying to write secure code, you don't hard code usernames, passwords, secrets into the code base. The way that you do that is with environment variables. But obviously, how do you access those environment variables within the code itself if you're not hard coding them? We can use Java Lang system again. This chunk of code here might be a bit overwhelming, but I'll walk you through it. I use this in all of the API wrappers that I write. There's an example of one linked at the bottom down here, but it's used in all of them. And it's up at the top. And what I do is I create the system class, and then I loop over a bunch of environment variables that I'm looking for. I can then use system.getEnv. That .getEnv method is how we get the environment variables, and I see if they're there. I try to get them. If they're there, I set them, and then I continue to the next in the loop. But if they're not there, what I do in this method is, along with checking for environment variables, I check for Java system properties, which we can also do with Java Lang system. So I check for if the secret is set as a Java system property, and then set it there. All of which is to say, if you need to get environment variables, you can use Java Lang system with the getEnv and getProperty methods to get and set those in your code. And that helps you write more secure code. And you can see an example of it in that API wrapper that's down at the bottom there. Now, again, do you need Java here? ColdFusion 2018, and this was introduced in ColdFusion 2018. I have not seen it documented except for the fact that Charlie Earhart wrote a blog post about it, and I checked it. But in ColdFusion 2018, environment variables were made available under server.system. So server.system.environment, and if we run this, again on TryCF because it's locked on CF Fiddle, we can see the environment variables that are available, and we could reference specific ones if we were looking for them. So you might not need Java because you can access environment variables on ColdFusion 2018 and newer, just natively with ColdFusion. How do I write to standard out? If you're developing for containers, one of the ways that you debug what's going on is writing to standard out. So how would we do that with ColdFusion? Well, we would do it with Java Lang system. You'll see here, we do a create object, and we do that .out to write to standard out. We use .error to write to standard error. And then we can use standard out.println, whatever we want to write, or standard error.println errors. I did this with a command box server just before this, and that's what the output looked like in the console for the server. Now, you might want to do this in a slightly nicer way, write a function to write to console, pass in the message, add a timestamp. And you could do that. This is an example of how you might do that. You write to console and get something with a JSON message and timestamp. If you're using something like Datadog, where they parse JSON logs, this might be a method to do that. I would be remiss if I'm talking about logging to not mention Logbox. Logbox is a fantastic, it's from the folks at Ortus Solutions, fantastic logging solution. It can log to standard out, and the way that it does it under the hood is this method using Java Lang system.out, but it provides a host of other logging solutions. So if you're in containers, use Logbox or use Java to write to standard out and standard error. Now, actually, this is the last of the Java Lang system answers that I'll be exploring, but it was actually the first one in my developer history where I was looking for a solution in ColdFusion and was ultimately directed to Java. Sometimes you need to write new lines in ColdFusion if you're generating a CSV or content for a text area. So how do we do it? We do it with the system property line separator. And what's nice about this is you can set that new line value equal to system.getProperty line separator, and it is system agnostic. So the line separator will be different on a Windows or a Linux machine, but Java will know and will give you the one that you want. So using this is a platform agnostic solution for getting that. Moving right along, this example is going to be slightly different than the other ones, but I found it very amusing. I thought it was worth sharing. How can I tell if it's a leap year? Now, this block of code is going to look different from every other block of code that I've shown. It uses Java util Gregorian calendar, and when we run it, this particular block of code is checking if 2001 is a leap year, which it was not, and it tells today's date. Why is it checking if 2001 is a leap year, you might ask? It's because this block of code, basically verbatim, is from a presentation that Charlie Earhart gave 20 years ago in 2001. This is 20-year-old code that still works. And it was a presentation on using Java in ColdFusion. So super impressive that the code still works, although I will say it is not necessary anymore. There is a built-in is leap year function that provides that functionality now. But 20-year-old code, blew my mind. Moving right along, next question. Can I preserve the order of keys in a struct? This was one that I had a bunch of times earlier in my developer career. Sometimes the solution, frequently the solution is don't use a struct, then just use an array because order is preserved there naturally. But there may be times that you need to preserve the order of keys in a struct. And the way that we do it with Java, well, I think there's more than one way, but one of the ways we can do it with Java is Java util linked hash map. So we create a linked hash map, and then as we set keys in it, their order will be retained. So we can run this, and you'll see that the keys, the order of the keys is maintained because hopefully you know, otherwise it'll come back to bite you. Structs in ColdFusion by default don't maintain order, or they're not guaranteed to maintain order. So you might stick them in one order and they might come out in the same order or a different order, which can definitely bite you if you don't know that. If you need to maintain order, linked hash map will do that for you. Now, again, you might not need Java here. In ColdFusion 2016, ordered structs were introduced. So you could do struct new and define it as being ordered, and then it would maintain the order that is used when keys are inserted into it. And you'll see here, we'll run the same thing, and the order is maintained. And you'll see in the dump here even that ColdFusion knows that this particular struct is an ordered struct. So ColdFusion 2016 and newer, you can make ordered structs natively in ColdFusion, but in previous versions, a linked hash map would be your solution for maintaining order of the keys in structs. Moving right along, how do I create a standardized or a standard UUID? Now, UUID, the spec was defined by Microsoft, and the UUIDs, the universal identifiers that ColdFusion generates, are slightly different than the standard format defined by Microsoft. Microsoft's have an additional dash that's not present. If you're trying to generate UUIDs, they're going to be used in a database that has that standard UUID format. Is there a way we can do that? And yes, there is. Java util UUID. In this example, we create that class, and then we use the random UUID function to string, and it will output a standard UUID for us. You'll see here, when we run this code, the top example is Java's UUID, and it has an extra dash, well, not extra, a standard dash here, and that dash is missing in ColdFusion's create UUID function. It's a thing that can come to bite you if you don't know that difference and know how to generate a standard UUID. Now, it's a difference of a dash. So there's a function on CFlib that just sticks that dash in for you. You could certainly do that. And there's also a link here in the slide to a guide to ColdFusion UUIDs if you're interested in learning more about them. How do I return the local host name of the server? So this is one that I thought might be of interest, Java net inet address. So I've created a wrapping function here called getHostName, and it creates that class and then runs the getLocalHost, getHostName functions and returns that. The reason I included this is because this function, getHostName, more or less is verbatim in the code for Framework 1 and also ColdBox. And you can use this to control the environment, to check whether it's your QA server or your production server. There's a link there in the notes where Sean Corfield from Framework 1 explains how that might be done. So that could be of interest to you. I also have a link here to the Java net inet address. If you search that class on CFlib, you can see some other things that are possible with the class, such as sending packets, getting all the A records for a domain, et cetera, et cetera. How do I work with Unix epic timestamps? So if you have to do any interactivity with JavaScript, other languages as well, Unix systems, you might have to work with timestamps since the epoch. So this is the number of seconds or milliseconds since midnight on January 1st, 1970. And interacting with that with ColdFusion can be a bit of a pain. You can certainly do it, you know, set a date, do a date diff in seconds, but we can do this natively in Java using Java time instant. So the first thing we have here is a timestamp. It is the number of milliseconds since midnight, January 1st, 1970. What we do is we create a Java time instant class, use the of epoch milli function, and pass in that timestamp. From there, we can then create a Java date, which is compatible with ColdFusion's date. And at the end, we run a date format on it. So we're going from that epoch date in milliseconds to a human readable ColdFusion date. And that date, Thursday, November 18th, was when I was writing this particular slide. So from here, we're going from epoch date to ColdFusion date, but obviously we'd probably want to be able to go the other way as well. So we can also use Java time instant and use the parse method on it. You'll see the parse method here. Pass in a date time to create that instant. And then from the instant, we can call to epoch milli, which will give us the number of milliseconds since the epoch for that date. Or if you need to do it for now, get an epoch timestamp for now, we can also do that by creating an instant, calling the now function. And then in this case, we're getting the number of seconds since the epoch. And you'll see, since we're doing it for now, that it will increase 1 second at a time. This can be really helpful. Like I said, I needed this a couple times when I was interacting with JavaScript. Either they were providing an epoch timestamp or I was expected to provide one back. Can I gzip text strings? So I ran into this. We know that we can gzip data coming back with CF header. We know that we have CF zip. But in this case, the issue was wanting to take a text string and gzip compress it, but not actually write it to a file, just get the compressed text string. And we can do that using Java util zip gzip output stream. So there's a function that I'm showing here, and this, I think this originated on CFlib. I have a link down there that takes a string. So we'll pass this fairly long string into it. We'll create a byte array output stream, a gzip output stream. We'll write the string to it. close it, and then return the value. And so if we run this, we can see that the original string, sorry, let me actually run it to tell you. The original string was 758 bytes. The gzip string was 568. So we got a little saving there, gzipping the string, and you can see what that gzip string looks like up top. If we're zipping strings, obviously we want to be able to unzip those strings that we've compressed, because it'd be pretty useless if we couldn't. We can use gzip input stream here to do this. And this function here takes the result of the previous slide and ungzips it back to the original string. My use case here was I was writing something that was a little bit long to a cookie, and I wanted it to be smaller, as small as I could possibly make it. So I was gzipping the text strings. But you might have other cases where you want to get a little extra compression on your text data. How can I easily parse URLs? Parsing URLs is a constant issue. It comes up in all sorts of applications. And the way we do it is not regex. You'll be happy to know. It's using Java Net URI. This is a class for parsing URIs, Universal Resource Identifiers. So in this example here, we are passing in a URI from my blog. Then we are running it into the Java Net URI class here in that init method. And that gives us access to basically every component of the URI. So we'll run this example here, and you'll see that it gives us the host, the path. If there were query params, they'd already be broken out. It grabs the fragment, that is like the hash sign after the host. Gives you just a breakdown of every component of the URL. Which can be really useful if you need to parse URLs. I've used this in pretty much every application that I write. At some point, I'm parsing a URL, or rather a URI, because there is a difference between a URI and a URL. If you're doing parsing of a URL, use Java Net URI. Java Net URL is a little bit different. A URL is different from a URI because it is a universal resource locator. So for one, Java Net URL needs the entire path. It can't just take a fraction of it, but Java Net URI can. And also Java Net URL in some of its operations is blocking because it actually does the location. It does a DNS lookup on the URL, and that can cause problems. So generally, you're going to be using Java Net URI. If you're interested a little bit more in that comparison and the reasoning, there's a link down there at the bottom to baildung.com, which compares Java URLs versus URIs, which I found clarifying and helpful. Can I generate URL safe base64 encoding? Now, base64 by default is not URL safe because it includes plus signs, slashes, and equals. There may be times that you want to pass base64 encoded information via a URL. And so it's nice to be able to do that in a established way. Java has a base64 class that has a get URL encoder without padding encode to string method, which can do this for us. This example, by the way, is taken from one of Pete Freitag's blog posts, and that's linked there in the notes. What we do here is we take a string, subjects, question mark, query param, and we pass it in, and we'll take a look at what the results are. When we run it with ColdFusion's toBase64 method, we get a string that has a slash and 2 equals signs in it. So not URL safe, but Java's URL safe version removes those and standardizes it so it is safe to pass in a URL. And obviously, if you are encoding these for a URL, you're going to want to decode them, and we can also do that. Java has a class with the Java util base64. There is a get URL decoder method along with decode, and this will take that string, the result of the previous slide, and decode it back to the original value. So you can go both ways. Again, it's important to be able to do that. All right, how can I randomly shuffle elements in a list? This might sound like a silly and useless question, but it arose in a real situation. I was writing an API wrapper for Algolia, And one of the things that they said you needed to do was they had a list of fallback hosts if requests failed, and their recommendation was to shuffle those, to randomize them when the component was init. So when you fell back, it was a load balanced across their different hosts. So how would I shuffle? How would I randomize the elements in a list? I would do it with Java util collections shuffle. And actually, if we hop back there, I have a link at the bottom to that Algolia CFC, so you can see this actually used in the project. In our example here, I've got a list of books, and then I am creating Java util collections, and I'm calling this shuffle method on the books, and then I'm dumping the result. If we run it, you'll see that in my array, Pilgrim at Tinker Creek is the first element in the results Pride and Prejudice is. If I run it again, it'll get shuffled again, and we are at Long Day's Journey into Night First. So it will keep shuffling them. That solved that problem for me. Now, the next thing that they needed me to do was rotate through those hosts. So if one failed, it needed to be moved to the end of the list, and everything else shuffled up. So if we need to rotate to cycle through the elements in array, Java util collections has a rotate method that does that. So I use this in the API wrapper again, and it rotates through array elements. Basically, it shifts every element one position. So if we run this here, you'll see Pilgrim at Tinker Creek starts at the top, but after we rotate, it is moved to number 5. And when we rotate again, it shifts up to number 4. So each call to rotate shifts every element in the array one position, or the number of positions that you ask for it to be shifted, which is a really helpful function. There's a lot more that's helpful with collections. You can reverse the elements in an array. You can pick the min element, pick the max element. You can swap elements at a particular position. I encourage you to check out the Java docs to see what else you can do with those, but they're really handy when you need to manipulate arrays. All right, can I perform DNS lookups? Yes, you can. This is a fairly large function in your face, and I'm sorry about that. You can take your time to look through it. If you're interested, this is again from a Pete Freitag blog post. What this element does is take a domain and an MX record type and then returns those MX records. So in the example, I'm looking up, actually, I'm saying MX records, I mean DNS records. In this example, I'm passing in my website, mattclemente.com, and asking for MX records. And you can see that my MX records are with Outlook. In terms of practical utility, the way that I've used this is, along with checking if an email address is valid, you can run requests like this to confirm that a domain actually has MX records. That is, it's able to receive the emails that you send to it. So there's some practical utility in this, along with any other reason you might want to do a DNS lookup. All right, last element of the standard library that I'm going to be running through. How can I do faster string concatenation? Here's the problem. I'm going to run this code, and then I'll walk you through why it's a problem. And this is going to be the slowest portion of the whole presentation, because no, your screen has not frozen. This takes about 10 seconds. I'll walk you through what happened, but you saw that it took 10 seconds to run the code. What this does, well, we're starting the timer. We're creating a new line separator. This is the generation of a CSV. We create a CSV string with an email and a random number as the first columns, a new line, and then we're looping over from 1 to 50,000. This is just to simulate generating a fairly large CSV. And in the first column, we're adding the email address, then we're adding a random number, and then we're adding a new line. And then you saw we dumped the result about 10 seconds. The problem is that ColdFusion strings are Java strings, and Java strings are immutable. So when you're doing string concatenation, it's not just merging them together. Every time, it's creating a new string. And when you're doing fairly large string concatenation, this adds up fast, and this gets slow fast. So we need to fix it, obviously. Once you know that the problem is immutable strings in Java, you can try to solve it with ColdFusion, and you can say, okay, instead of having 3 separate elements of string concatenation, I'm going to reduce those, and I'm just going to do 1. And when we run this, it goes from 10 seconds to about 3. 1, 2, 3, a little longer than 3, slightly longer than 3 seconds. So we've really cut down the time because we knew what the problem was. But 3 seconds is still a bit much. And for more complex problems, more complex string concatenations, obviously this is going to be untenable. Enter Java Lang string buffer. You're going to find a lot of blog posts from around 2008 touting this as the solution, and it does save you a lot of time. So we create a string buffer. A string buffer is what Java gives us instead of immutable strings. This is here so that we can build long strings. And we will append the first line, and then within the loop to 50,000, we will append the email address, the rand range, and the new lines. When we run this code, remember it was 3 seconds before, and this gets us down to about 300 milliseconds. So substantially faster. Everyone who blogged about it being faster is absolutely right. It's a better way to do string concatenation. However, you might not need Java here. There are ways to do this in ColdFusion that might actually solve your problem. And the first is, instead of doing string concatenation the whole way, to use an array. So what we do here is we make an array. Within the loop, we append elements to the array. We create our new line character, and then we convert the array to a list. But instead of using a comma, the list is separated by new lines. So we get our CSV with everything on a new line. And when we run it here, remember we were at 300 milliseconds last time, this cuts us down to 54 milliseconds. So we started at 10 seconds, we're down to 54 milliseconds. And that's natively using ColdFusion, but we can actually get one better. The third solution is to use CF save content. CF save content rescues us from the string concatenation. Within this, we do the loop inside of our save content tag, writing out the email address, random range, and new lines. And when we run it with CF save content, we will be down around 30 milliseconds. So you can do very fast string concatenation with ColdFusion if you know what you're doing. Using save content is a big trick there, although string buffer is faster than ColdFusion natively. So go ColdFusion. All right, there's a lot more classes, but I'm down to not a lot of time left in my session. These are all links to the Java docs for other classes that you might want to look at. I will point out, I have links under every one of those classes to the Java docs for them. So you can see an explanation of the class and all of the methods that are on it with explanations. That's really helpful if you want to explore and see what you can do with the classes that are available in Java's standard library. All right, community libraries. These are lots of fun. These are the code that Java developers have written to do absolutely awesome things, and they've written things to do basically everything. The community libraries are generally provided as jars. What's a jar? It is a Java archive. Basically, it is a zip file, and it contains all of the classes, all of the Java files necessary to do whatever the community library provides. We need to load these jars into our application so that ColdFusion is aware of this code. And we do this in this .java settings, which is in our application.cfc. In this example here, I'm showing you all of the options and defaults, but the one we really care about is load paths. It's the only required one. And what it is an array of directories or file paths that contain jars or classes. And you can load in some other stuff there, but that's what it's meant for. Here are two examples of what that might look like in your application CSC. The first is, I believe, a Windows setup where the first one is a path to some particular jar you want to work with. The second is a path to a Java lib directory. The second one is a way that I like to load my jars. I use directory list. I stick my jars spaced by community library within a lib folder, and I recurse down through that, grab all the files, and use that to pass them into my Java settings load paths. So that's another approach to getting them in there. The Adobe link at the bottom, Adobe Documentation Enhanced Java Integration, discusses all of this in a bit more detail. But without further ado, let's actually dive in and see what some of these libraries can do. JSoup was, I believe, the first Java community project, community library that I started using. It's an HTML parser. It's basically jQuery for the server. It gobbles up HTML and then gives you a nice interface for iterating through it, manipulating it, etc. As they say, it's for editing, cleaning, scraping, and cross-site scripting safety. Go to the JSoup site. It's linked down there, JSoup. They've got a cookbook showing stuff that you can do. It's a helpful walkthrough for how to use it. I'm just going to give you one example here. So here is our example application structure. We have a lib folder with the JSoup jar in it. We have our app CFC that is loading up that jar in this .java settings. And we have our index where we're going to be running this code. And in this example, we're going to be parsing HTML. So we create our JSoup object using create object or JSoup. Then what we're doing here is JSoup's actually connecting to my blog, JSoup Connect, and getting the page that's there. It parses the page, and then we can look at the elements that are on the page. So doc.title, that helpful title method there, is grabbing the HTML title of the page, and we write it out. And then, like jQuery, we can use this select method. And in this case, we're passing in this particular selector, all the ahrefs, and they're getting put in that links variable as an array. And in this example, I'm looping through the links, and I'm showing you what the text of the link is and what the href element was. If we ran that code, I ran it just before this session, you can see we have the page title of my blog, Matthew J. Clemente, and then here is a list of the href tags with their text that are on the page. There's a lot more you can do with JSoup. You know, go out there and explore, look at the docs, but it becomes fun working with HTML and see what you can do. It's a very powerful community library. Antisamy is another library for working with HTML. It is for cleaning HTML that comes from untrusted sources. There's a whole backstory about why it's named Antisamy. Don't have time to go into that. Let's just look at how we can use it in our ColdFusion projects. As with last time, here's the structure of the project. We have a lib folder with the Antisamy jar. And in this case, the way that you configure what Antisamy does is with an XML file. And that XML file defines what HTML tags you're going to allow, what attributes on those tags you're going to allow, even what values for the attributes you're willing to allow. So you can get very granular about what is acceptable HTML and what is not. So we're going to load that up, and we will sanitize some HTML here. The first line, we create our sanitizer using create object, org, OWASP, validator, HTML, Antisamy. I should have mentioned Antisamy is part of the OWASP project. We create a path to that XML config file, and you can have as many different config files as you want. So in some cases, you want very strict HTML validation, and in some cases, you allow more liberal use of tags. Do it however you want. We have our unsafe string here. In this one, there's an H1 tag, which has an on-click element with some malicious code in it. And we are going to pass that unsafe string and our policy file into the scan method of Antisamy. And then here, we're going to output the result. The result, so we have two methods we're going to look at here. It has more than this. One is get clean HTML. So it takes that unsafe HTML, strips out everything that doesn't fit in your policy file, and gives you the cleaned version. There's also a method to get error messages. So if it encountered any unsafe HTML, we're going to have an array here of all of the unsafe elements that it stripped out. If we ran that code, this is the result we get. I understand that that top dump is a little bit small, so I output it a little bit larger underneath. Our input was unsafe. You can see our cleaned input here has removed the onClick element. And in the errors array, we had one error, and it said the h1 tag contained an attribute that we could not process. The onClick attribute has been filtered out, but the tag is still in place. The value of the attribute was the malicious alert. So you can see what was actually done. Now, do you need Java here? It depends on your use case. In ColdFusion 11, the isSafeHTML and getSafeHTML tags were introduced. They use anti-SAMI under the hood. So isSafeHTML returns a Boolean value if the HTML is safe or not, and it can accept a policy file. GetSafeHTML functions the same way, cleaning out anything that's not safe. Two issues here. One is that anti-SAMI is a live project, and it's constantly being updated. So the version with ColdFusion is not necessarily up to date. But also, one of the reasons I like using anti-SAMI directly is because it returns that array of errors. So I can see what's going on and what needs to be fixed, or what malicious stuff is being presented. Now, I've got 5 minutes left, so I'm going to run through this fairly quickly, but I think we'll be okay. YAML is a community library for reading and generating YAML files. So in this example project, this would be set up the same way. If we had a YAML file with this structure, we could create our YAML object, create a Java file instance loading up our example YAML file, and then use YAML to parse it. And what that does is it takes the YAML file and breaks it down so that we can actually get, a code representation of the keys and their values. So we can iterate over it in this example here, get the keys, show what their values are, and we can even grab the comments, is what that last example shows. If we did that, we'd get this parsed version. All right, I got 3 minutes left, so I'm going to wrap this up. It can also be used to write YAML. So in this example, here's our code that would generate a YAML file that looked like this. All right, AWS Java SDK, super big, lots you can do with it. If you want to use it, here are some resources. Brian Class is the AWS guru. He's got a ton of blog posts on using the AWS Java SDK with ColdFusion. He also has a Playbox app on GitHub that shows the code being used. And I have 2 repos there where I base my code off of his and have wrappers for interacting with S3 and with AWS Lambda. There are lots of libraries in Java for doing super cool stuff. Take a look at them if you're interested, particularly security stuff, some really awesome things for hashing. And finally, there's more to explore. So Bolt HTTP uses Apache Commons. Pete Freitag wrote that. There's a ColdFusion. Brad Wood wrote something to interact with Java's Playwright library for using headless Chrome. There is now a CFML SDK for using Launch Darkly, which is it's a wrapper for a Java library that has feature flags. And finally, PDFbox CFC is a ColdFusion wrapper that I wrote for working with the PDFbox project, which is a jar that enables you to manipulate PDFs, and it's really powerful. Finally, this is the end of the session. Here are some of the resources that I used in putting this together if you're interested in learning more about using Java with ColdFusion. And that last link there is the GitHub repository, which has some of the code from these slides. Thank you so much. I'm on the CFML Slack channel. I am on Twitter. All that information is here. So if you have questions, please feel free to reach out to me on any of those platforms, because I think my time is pretty much up. I'm sorry that I went down to the wire and didn't have time for sessions, but I really appreciate everyone being here. And hopefully, you can connect with me later if you have questions. I'd love to answer them if I am able to. Have a wonderful day. Thank you.